Hello everyone, April 15th. Look, we got another difficult one today. This must be new. Never seen this one before. Number of ways to form a target string given a dictionary. You're given a list of strings of the same length, words, and a string target. Your task is to form target using the given words. Under the following rules, target should be formed from left to right. To form ith character of target, you can choose the kth character of the jth string in words. Kth character of the jth string. Once you use the kth character of the jth string, you can no longer use the xth character of any string in words where x is smaller or equal to k. So that's almost the same as what we have yesterday. In other words, all characters to the left of or at index k become unusable for every string. Repeat the process until you form the string target. You can use multiple characters from the same string in words provided the conditions above are met. Return the number of ways to form target from words. Since the answer may be too big, you have to do this. The number of ways, 1000, 1000. Target length is 1000. So I think it's almost exactly the same. Those are just piles, right? And then you're taking, I shouldn't say exactly the same. You have piles, and each pile you can say I can use the first word or use the first two words, but of course you cannot use the first two words. So what we need is the index for words, that's for the DP, and the second will be the index in target. And then we're saying from the index in the words with index in target, what is the total number of ways that we can form, right? Yeah. And that shall be it. Okay, let's code it. Oh, sorry. Okay, let's code it. Okay, func tools. All right. So def dp, we have I, j, int, mod is 10 to the 9 plus 7. Okay. And then we have, let's say n, line words, len target. Okay, so what do we do? Well, it's the same thing, right? So we say if I is equal to larger equal to m, or j is larger equal to n, the r is 0. It's an impossible case. And then we can say what we can say is starting from the first one, right? We see if we can take it. Right? If we can take it, then we take it. If we cannot take it, we can always say we cannot take it, right? So rest shall be we cannot take anything in the ith pile. So that should be dpi plus 1 j, right? We cannot take anything in the ith pile. And now I say, okay, let's see if we can take something from the ith pile. So you say for k in range words, so that's actually yeah, for k in range len words I. Okay, so we say if words I all the way to k plus 1, right? Because all the way to, if this is equal to target j to j plus k, well, k will start with 0, so it should be plus 1, right? From this, if k is 1, then we have 2. 1 be plus 2 plus 1 plus 2, yeah. So if these are same, then we can say res will equal to res plus dp I plus 1 and j plus k plus 1, right? I plus 1 the next one, and then we already handled j, we'll handle from j to j plus k. Okay, and now we're gonna mod. Okay, if it's equal to, and else if it's not equal to. Well, if it's not equal to, that just means, does that mean we break out? Yeah, I think it does mean we break out, because if it's not equal to, that just means the current stretch in this current pile, it just no longer works. So if it no longer works, then we just break. Right, we'll break. And now I return res. And now we just return dp from 0 and to 0, right? Okay. Value cache. All right, let's try this. Yeah, I mean, if you just keep practicing on the same type of problem, they do become, I won't say easier, but it's, you have an idea of where to start. And sometimes that is the most important thing. You need to know where to start. When you look at a problem, you need to have a general idea, okay? Based on the way the question is asked, based on the constraints, what type of problem are we expecting? So that is kind of important. Okay, what was wrong? I didn't get anything. It's interesting how I'm not getting anything. Because I think you just keep going, and then at the end it just gets out. You never return 1. Yeah, I didn't prepare the end condition right. So what is 1? Well, 1 is if j is equal to n minus 1. Wait, hold on. If j is equal to n, right? If j is equal to n, and I is, okay, if I is larger than m, then that's definitely, we're ending, right? If j is equal to n, right, that's 1. We have to find 1. Maybe we should say or j is larger than n. Wait, hold on. If we exhaust the words, but we haven't matched everything, that's bad, right? And If we match, yeah, I think that should. So if we exhaust but we haven't matched everything, that's bad. Yeah, that's the only case that's bad. So we can always move on, right? We can always move on. And the good is if j is equal to n, then it's good, right? It's good. I think that should suffice. Nope. Still not right. Okay, let's take a look. Now we have to take a look. All right. Let's take a look. I, j, and res. So we start with 0, 0, right? And then, you know what? Let's put it at the top. It'll be easier for me to reason the prompt. So we go with 0, 0, and we match. No, we do this first, right? And we do 1, 0, and we do 2, 0, right? And we do 3, 0. Well, that's bad. That is bad. Then I do 1, 1. I go to 1, 1. Hold on, why do I go to 1, 1? 3, 0 is bad. So we are at 2, 0. Right? So 0, 1, 2. 2, 0, and then we will try the first one. Then boom, it doesn't work. Right? Then we go, when we are at this, try the first one, doesn't work. And then we are at this, the first one, it works. Right? Then I went 1 and 1. So 1 and 1. 1, 1, we go 2, 1, 3, 1. Then we got 2 and 2. Right? So 2 and 2. Yeah. Because it works. And 1, 1 it works. So 0, 1, 2. 2 and 2. It doesn't work. Oh, that's not right. That's not right. What the hell are you doing, man? It should be 1 by 1. It should be using 1 by 1. It's not it's not, I understood the problem wrong. So it's just 1. You just pick 1. You just can't pick another one. Like if we can have multiple, then we shall do, then we are allowed to pick multiple, right? So if the first one doesn't match, we try to match the second one, right? If it match, we can try to match 2. Multiple characters from the same string. Hold on, let me think again. If I match this current, yeah, so if I match one, okay, what I can do is I can match another one, right? I can try and match another one. So for each one I shall match. If the first one doesn't match, this one needs to change, right? So if the first one match, then I move on, and we can also match multiple. We can match 2, right? We can match 2. And whenever it doesn't match, then we go for the next one. So I think we have to change this. Let's go P and Q. For P in range this, right? And then we can say for Q in range P plus 1 to line words I plus 1. This is extending the range. Actually, I'd rather do this. Okay. Now we say if, right? If words p to q plus 1 is equal to this, j to j plus, well, q minus p plus 1. Then I do I plus 1 to j plus q minus p plus 1, right? That's like if one match, we do it, and then we try 2, we try 3. Whenever we don't match, we can break this up. Then we have to try a new thing. So with that, then I have too many. What the hell, man? Then I have too many. I do not like this. Why would I have too many? I'm gonna try to find like all, right? I try to find all possible, and if I match something and I run out of things to match, yeah, that should return 0. Oh, I think it's the same issue. If it returns 0, that means it's a failed match, right? If it returns 0, that means it's a failed match. And if it's a failed match, we shouldn't. But it's fine. If it's a failed match, we just plus 0. So it'll be the same thing. It doesn't matter. Okay. What? 2, 0. That's a 0, okay. 1, 0, that's a 0. 2, 1, 0, 1, 2, 1, that's a 0. 2, 2, 2, 2 is 2. That's correct, right? This is 2. That's 2. We can have 2 matches to the A. That's a 2. And 1, 1, 1, 1. I mean, honestly, 1, 1 should be. Should have 4 different ways to match. No. 1 and 1. Only 2 ways to match. One is 2 ways to match. 1 and 2. And then immediately 0 and 0. 16. That is not right. So I think I'm doing A, because this BB, right? And this A. No, I say 1, 1 has 8. What? 1 and 1 have 8 ways to match. That's not true. Huh. Let's read it again. Once you use the case character, you can no longer use anything from the previous. Okay? So I say if I use this to match and it doesn't match, then I can try. Wait, hold on. If I use Yeah, I just cannot use the previous. So I can use this to match. And if I use it, I cannot use the previous to match. Once you use the case character, you can no longer use the X character from any string in words. Which means if I use this, wait, can you even use multiple? Once you use the case character of the jth string, you can no longer use the X character of any string in words, but X is smaller equal to K. All characters to the left of become unusable for every string. For every string. That's the thing. For every string. So if I use the first one, then I can no longer use the first one. I must start with the second one. See, that is where I missed. Which means, oh my god, so I need 3. Are you kidding me? We need to use 3. No, we don't need to use, wait, hold up. Do we need to use 3? Oh god. We might have to use 3. Which is the maximum, right? The maximum index that's been used so far. The maximum we've been used so far, so I have 3. And that's 1000 as well. Okay, max index. Okay, this is still good. This will be max index. For P in max index. No, I call it start. SI, start index. Yeah, whatever start index we can use. So it should be from start index. And this is the same. Right? And then whatever, because I'm using multiple. Yeah, I can use this. Can use multiple characters from the same string, provided the condition. How would you use multiple from the same string? You can use the first one, right? And you can use later on something else. And you can use, and you can come back. Oh my god, you can come back. Like if I use, I don't know if it's, yeah, this doesn't have this example. Index 0 of this, index 1 of this, index 2 of this. Oh, this is different. Or index 0. Because if you're gonna do it, I'll say I'll start with this B. Right, and then now you're starting with index 3, so both you look at index 3, so I can have a B. No, index 2, and then we can do another B, so I only do 1. Now I miss the other 3. Dude, hold up, this is not right, because you can jump back and forth. Yeah, the order. So we're saying okay, let's regroup. Let's regroup. So what should we say? We shall say I'm at the words, right? And then, like in this case, I'm at the first one, right? And now our target is to match the last B, okay? Which is perfectly fine. We can do that. Which means at each index, I shall try to match, or each index and every element I shall try to match. That is not here nor there, man. So we have target, right? We have target. First one, if we want to match in the target, is a B. Now we can go through everything to find where the B's are, right? We can find where the B's are. Okay, we find the B's are, you know, here, 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 here. And then we get the next position, possible position, right? And then next one's A. So among all these positions, which one is an A? So you look through all those positions and I try to find the A, the next A. And once we find, I want to find the next B. But then that is going to be a long thing. And it says the result can be huge, so I don't think that's the way to go. I'm thinking again. If we start from the first one, right? If I start from the first one, right? Now we need to find a B, okay? We got a B. Now, and also because you can take any one, right? You can take now the index move forward, okay? Index move forward. So at this position, at the position, okay, how about this? At each position, what letters do we have? How many letters do we have? For example, in the second example, at position 0, okay, we have A, 1A at position 0, and a 1B, that's it. At a position 1, we have 1A and a 1B. At position 2, 1A, 1B. At position 3, 1A, 1B. Okay, at each position we have 1A and a 1B. Now, the target. The target is BAB. Okay? Target is BAB. Therefore, I can say if, right, if we start from the first words, at position 0, okay, we have one option, right? If the position is, well, I mean, we can have multiple. Yeah, we have like many different positions, right? And we look in them and see where can we get BAB out. and say, okay, we can do a 0. Do we have a b? Yes, we have a b. Okay, that's it, 0. And then 1 we have, and then 2 we have. Done. Right, done. Now I can say, okay, I don't want to do 1. Right, I can do 2, so I can do 0, 2, 3. Right? Or, yeah, that's that. Or I can say I don't want to do 0, I can do 1. I can do 1, 2, 3. That's an interesting way to think. And if I can do 0, 1, 2, I can do... Can I do 2, 1, 0? No, I cannot do 2, 1, 0. Because the position has to go from small to large. Right? It has to be from 0 position, 1 position, and 2 position. So 0, 1, 2. Right? 0, 1, 2, 0, 1, 3. 0, 1, 2. Oh, I forgot the 0, 1, 3. Yeah, this is actually the hint is giving you. That's actually how it's supposed to be done. Okay. So what we're saying is we're going to redo this. We do, for each index, give me a counter of everybody, right? And then we'll do DP based on that, which is from this to the end. What's the total number? Can we do it, better? How can we do it better? So at each index, we can say, okay, I will try to match the current letter. Can we match it? And the answer is yes. Okay, so either we can or we cannot. I mean, yeah, we can, then we match it, then we try the rest. If we cannot match, or we can choose not to match. That's why we have 0, 2, 3. So 0, 1, 2, 0, 2, 0, 1, 2, 0, 1, 3, 0, 2, 3, and then 1, 2, 3, 4. Okay, let's change the strategy. This is all fine. So I need a default collections. Let's get counter. Okay, so what I want to do is at each position, oh Lord, each position for I. Actually, I don't even know how many positions there are. I do not know how many. I have no clue, but it's fine. It's okay, right? It's okay. So I will say for word in words, okay? And then I need the counts. Let's do counts, counter. Oh, that ain't counter. That ain't counter. Right? And then we just say for I, W enumerate words. Okay? If I is equal to count, len counts, which means we haven't hit there yet, then counts.append a counter. Then we say counts I, right? Counts I this plus equal 1. Okay, so we have this, and the next word. So now we have counts. Okay, now we can do this, I and j. Then we don't need this. Okay, then we say, well, what's this? So dpij, right? dpij is the total number of ways to form target j to the end using counts I to the end, right? From counts I to the end. So if that's the case, now what do we do? Well, we shall still say if I, you know what, maybe we can, don't do this. We say if I is larger or equal to len counts. How about that? Right, so we exhaust, and then j is smaller than len target. Then return 0. That means we have exhausted every single position, and we still cannot make target. Or, right, we say if j is equal to n, and doesn't matter, I can be larger or I can be small, and that means we find one, right? That's a 1. Otherwise, we say this is we skip, right? We skip the current. Or we take the current, right? We take the current. Well, we have to know, right? We can say if at the current position do we have it, right? If at the current position we don't have it, then this is the moot point. I say if target, right, j is in, right, is in counts I. If it's in it, right, if it's in it, or even better, let's do it this way. If counts this and this is larger than 0, then res equal to res plus dp I plus 1, right? We take it, and then j plus 1. We take the current, now we move on to the next one. In the current position, if it exists, right? And all of this, of course, will mod. Then if it doesn't exist, then nothing. All right, let's try this one. Name n is not defined. Of course it's not defined because I have not defined it. Len target. What the hell? It's still not right, but okay. Let's take a look at the counts. See if counts right. Counts. What is this? What is this? Word. Okay. Answer becomes 6. Result is 3. Okay, I did not study this. I studied this, so we should try this one. This one does pass, but this one fails. Okay, let's take a look. Why? So at position 0, we have 1, 1, 1b, 1c. At position 1, we have 1c, 1b, and 1a. At position 2, we have 2 c's and a 1b. At the last position, we have 2a and b. Okay, so in this case, one form ABA, right? So we can do 0, 1, 3, okay? 0, 2. Now the problem now is I don't have enough. So why do I not have enough? Now I do not have enough because of this. Let's take a look. I say 0, 0 is 3. No, let's take a look at 3, 2. Okay, 3, 0, 1, 2. At the third position and 2, I have. Oh, I shall change this. Shall return if j is equal to. That is not what we're trying. Hold on, almost there. Hold on. We have to count the multiples. I did not count the multiples. I know. So, if it's in, right? If it's larger than 0, then everything needs to res or plus equal to this times this multiplied by right? it's larger than 0, it's going to be multiply. Why it's multiply? Because I can pick this or I can pick the other one. And that will be right. I'm tempted to reduce this and then just to multiply, because fine, because it's 0. 0 times something is still 0. But you kind of do have to go through this again, right? Do you think this is worthwhile? I actually do, because I know if statement is very slow. So in this case, I can just say equals this plus this, right? I don't see any issues. Let's also comment out this. I don't need this one. I don't need this one. All right. So we probably need to explain what is counts. Counts I is a counter that shows the number of letters that occur at position I in every word, right? Every word, if possible. That should be good enough. Okay. Now let's go in here and give this a shot. Give this a shot. I mean, it makes sense to me because runtime is also making sense. Hopefully this one goes. Hopefully this one goes. This one goes. This one goes. I mean, it's not. The DP part is okay. The tough part, the difficult part is figuring out this thing. All right? This thing, we need to use this. And of course, you have to understand the problem in the first place, which I did not, right? In the first place, I did not understand. I thought it was very similar to the one yesterday. You have to do like the full thing from the start, but no, it's not. It's just saying every time you use an index, then the next index has to be larger, right? And this actually gives you a hint. The way that it expresses, this is a hint. This is a hint. Right? You start with 0, next one has to be 1, next one has to be 3. Start with 0, next time I can have to go larger. And then it occurs to me that basically we do have an order. I mean, for DP, the reason that the previous one didn't work, that I realized that it's bad, is there's no order, right? If you just say, I want to pick this, right? And then I want to pick the second word. I want to pick the third word. Like if you want to do that way, it doesn't work because in this example, you can mismatch. You pick the second one first, and then you pick the first one. So it's impossible to do DP or do a state based on the indices of the words. But if it's a DP issue, if it's a DP problem, you have to, right? You have to find a certain order so that you can do your thing. And then the order is given to you right here. It's the index. It's the index you use, right? So if we're certain that we're going to do that, then the question is, okay, if we want to do the index, the first thing I want to know is whether at this current index, right, at index 0 of all the words, can I form a certain position in the target? And the natural solution to that is you want to set, but you also want to count the number, right? So then, okay, counter, right? Counter is the idea. So that's why we form the counter, right? Where counts I is a counter that counts the number of letters at ith position for each word, if possible. And then we do the DP. And actually, if you look at the DP itself, it's not complicated at all, right? It's very straightforward. So first of all, we have two edge case. Right? The first edge case is impossible. So what is impossible? Impossible is you run through all positions possible, but you still cannot form target. which is expressed in this way. You run through everything, it's not possible. Now, what's a correct, right? What's a correct is you have matched everything. You have matched target. So J reaches land target. So that is 1, right? That is 1 good result. And then you go to the actual result. So the first one we say, okay, so we can always decide not to match the current index, even if it can. We just say, okay, I don't want to match it. So this is I don't want to match it, right? And then we say I want to match it. If I want to match it, I need to know the total number of instances that I can match the jth letter in target with a current counter, right? If it doesn't exist, this will be 0. So we just do 0. If it exists, that will be a value, right? Multiplied by what we can match next. And then, booyah, it worked. Okay, it worked. This is what I will say a decent, medium, hard, right? It's something that if I put my thinking into it, and it's also quite early now, so no, the brain's still working, I can figure it out. First of all, one has to understand the problem, right? Understand the problem. Wow, that was my initial mistake, as I misunderstood. I misunderstood what the problem was asking for. And then for DP to work, right? To work, we need a certain order for us to traverse through all the states. And in this problem, the order is not the order in words, but the order of indices used from words, regardless of the actual words used, right? Thus, we must know what choices do we have at each index of all the words. We can use, right? We can use a list of counters, right? Where counters, list of counts, right? Well, counts I is a counter of all letters appearing at the ith index of all words. Then, for each pair of ij, where j is the current position in target to match, right? We can decide whether there is any letter in words that can match by checking counts I, target j larger than 0. Right. Of course, we can also choose not to use the ith index. Right? That's fine. Not to use the ith index. With these two conditions, the actual DP relation is not that complex to come up. I call it MN, okay, where M is the length. But actually, what's this one? we can say, let's say k plus, where k is the total number of letters in words. M is the longest, is the length of the longest word in words, and n is the size of target. It's okay, right? It's okay. All right, time to see solution. Bottom up, top down. Yeah, we can just see this one. Oh, they do alphabet. Yeah, it's fine. Yeah, see, this is the counter, right? This is the counter. I think J is minus. That's okay. It's the same idea. Result, right? That's the initial result. Is you'll skip, right? If you're gonna skip. Otherwise, you're gonna plus equal to count. Yeah, look. It's exactly what we have. Well, it's slightly different. They put the target first, and then they put this, but it's okay. Multiplied by this, which is the same as ours, and then do this. Yes, that's exactly the same. Exactly the same. Okay, why? There's another one? X. I don't know. I mean, it's quite clear, right? It's clear. It's clear to me the way that I handle it. Yeah. Yeah, I'm not doing bottom up. Problem that complex, I actually think bottom up is you're doing disservice to yourself. Bottom up, like you're really holding the whole problem in your head. That's how I always think about it. But the actual idea is, I think, not holding everything in your head, but to use recursion. Recursion restricts the complexity. It significantly simplifies. Like everything, like I'll just throw it to the next one. I don't even care, right? And all I need to handle is the current problem. That's the beauty. Yeah, I don't think interview they will ask you, oh, now implement this from bottom up. And I'll say, well, if they really ask that, I'll try, but I'll tell them that it's pointless. So why? And we've seen a couple of instances, right? If doing bottom up, it's actually causing more. It's longer, because you have to create the DP, right? Whatever matrices, you have to create it first, and the creation takes time. And when you do the cache, everything is optimized, right? It's optimized when you do the cache. So actually be more useful, right? Better just to do it this way. Yeah, I'm not reading it solution because the solution I think is pretty much the same. I don't know why they do the minus, right? It seems like they start from the end, so going from end to front. Probably makes sense if you do DP, right? It might make more sense doing it that way. No, we're doing plus, right? They're doing plus. Then I have no clue. Yeah, maybe look at this. This is exactly the same. Yeah, this is exactly the same. Okay, that'll be it. Took a while. But yeah, I'm glad that we got it done. All right, I will end it right here and see you guys tomorrow. Adios.